Hello folks, in this video I'm going to show you how to create a confidence interval with an unknown sigma around some sort of x bar. Often you're going to be given the x bar, but you might have to calculate the x bar, and I'm going to be using Microsoft Excel to do that. So this is the formula for the confidence interval that I'm going to be using. What do I need here? I need an x bar, t alpha over 2 and n minus 1. We're going to be using the student t distribution to find our critical values. I need the S, the standard deviation of the sample, and I need whatever is my number of values that were taken from the sample. So there's a couple of pieces I like to pull out and show you from this formula. This right here is my standard error. This entire thing right here is called my margin of error. And the entire thing together, of course, is called my confidence interval. Okay. So I have all of the pieces I need for this formula. So we're going to go over to Excel and we're going to create a template so we don't have to input this. All we have to input are these values that we're given and our confidence interval from now on if we create our template correctly. So let's move over to Excel. Okay. And I like to lay out all of my different pieces. So I got my X bar, I have my S, I have N, and I also like to minimize the amount of computations in some of my calculations. So I'm gonna make something for square root of N here too. I know I'm gonna need it, so I'm gonna put square root of N there. Now I need my confidence interval. Now let's talk about the confidence interval number and your critical value, this t alpha over 2. This t alpha over 2 is going to be derived from a student t distribution. And as you know, a student t distribution looks very, very similar to a normal distribution. There is some mean here, some mu. And this alpha over 2 is going to be some area under the curve. And this is my critical value, my t alpha over 2, n minus 1, where this area is whatever my confidence interval. Let's do a confidence interval of 93%. I like 93%. So 0.93 is going to be this area under the curve right here. That means this area and this area, which have to be the exact same, are going to be whatever's left. 0.07 divided by 2, 0.07 divided by 2, okay? So let's get this number where this area under the curve is 0.072 divided by 2. I'm gonna code this into a template so I only have to show you this image one time. From then on, you're just gonna be able to put the numbers in here, okay? So my confidence interval, I also need 1 minus CI divided by 2. I need one other thing to be able to use my t alpha over 2 to use t dot inverse, that function, to find my critical value. I need degrees of freedom. And if you remember, degrees of freedom is just n minus 1. Okay, and now I can create my t alpha over 2. I have all of the spots that I can populate. I'm also going to put lower and upper down here. So X bar here is 3.7, S is 1.3, N is 45. Now it is important to point out that if you don't know if the underlying distribution is normally distributed or not, make sure that N is more than 30. It is good I have more than 45 values here, okay? I need a square root of N, this 45. Now I also like to highlight the values I need to put in. So I'm going to go ahead and highlight these. These are going to change as I do more of these problems. This is also going to change. This is critical, this confidence interval. And for this problem, I'm doing a 93% confidence interval. 1 minus my confidence interval. Got to put equals or it's not going to see it as a formula. Squared. Okay, degrees of freedom. This is just equal to this minus 1 Now I have everything I need to do to use T inverse equals T dot inverse with my probability and my degrees of freedom. You'll notice that this number, so this number is negative. I don't like it being in a negative. So for my template, I'm going to make a negative T inverse. You'll notice that this number will get closer and closer to your approximation with a standard normal for your critical value as you increase the amount of observations that you pull from a sample. Okay, but for right now, so for instance, if I did 900, that's going to get smaller and smaller. But for right now, we just have 45 observations. Okay. So my lower limit, now I get to use this entire formula, but I have all the pieces set aside. So it's going to be a little easier of a computation down here. This is going to be my X bar minus my T alpha over 2 times S divided by square root of n. This is why I did square root of n up here, so I don't have to do it down here. Okay. This is also going to be X bar plus T alpha over 2 times S divided by the square root of n. So what this tells me is I'm 93% sure that the true mean of whatever it is that this population comes from is between 3.17 and 4.22. If you do not have your X bar directly in the middle of these two, you might want to take a look at your computations because I use this to calculate them. They should be right in the middle. So create yourself a template. It'll help out a lot.